Dear students, we are going to start the third chapter. It is motion in a straight line. This chapter you have learned in your class 9. So we are going to revise the content and further in depth we are going to learn about motion of a body in a straight line. So let's begin with the first one, mechanics. What is mechanics? Mechanics is a branch of physics that deals with motion of a body due to the application of force. So a branch which deals with the motion of bodies is called mechanics. There are two branches are there in mechanics. One is called statics, another one is called as dynamics. See their name itself, static. Static means rest. Dynamic means motion. So static. What is static? It is a study of motion of an object under the effect of forces in equilibrium. What do you mean by equilibrium? Suppose there are two forces acting on the body in two different directions. Both the forces are equal but acting in opposite direction and make the body to remain in rest. So the branch which deals with motion of objects under the effect of forces in equilibrium comes under statics. That means the body will not move. Dynamics. It is a study of motion of objects by taking into account the cause of their change of states. What do you mean by state of a body? A body can be either at rest or in motion. So, a branch which deals with motion of bodies which changes their state continuously is called dynamics. Dynamics is again classified into kinematics and kinetics. What is kinematics? The study of motion of objects without taking into account the cause of their motion is called kinematics. Generally, your motion in a straight line comes under kinematics alone, because nowhere else you are going to talk about a term called force. But you say that a body is moving with some initial velocity, after a certain time it has some final velocity and it has traveled certain distance, there is acceleration for the body, etc. etc. But nowhere else you are going to talk about the cause of their motion. Generally, what is the cause of motion of a body? Force is the cause of motion of a body. So in kinematics, you will not use the term force anywhere, but you're going to talk about motion of the body completely. Kinetics. Kinetics is the study of motion which relates to the action of forces causing the motion and the mass that is moved. So in kinetics, you will talk only about forces. Wherever you are going to find, you are going to talk only about force itself and the mass which is going to move. So kinematics you have studied in class 9 under motion topic, and kinetics you have studied under Newton's laws of motion. Concept of a point object. What do you mean by point object? In mechanics, a particle is geometrical mass point or a material body of negligible dimension. That means even though it has a bigger size, we are going to consider it as a small particle. So it is only mathematical idealization. So an object whose size is just like a point, by neglecting all the dimensions, is called a point object. Example. So if you compare the earth and the objects present inside the earth, the size of the objects are very small, so we can consider them as point objects. So I can take the ball as a point object, I can take the car as a point object, ship as well as aeroplane as point objects. In practice, the nearest approach to a particle is a body whose size is much smaller than the distance or the length involved. Position, path, and displacement. Before going to discuss about them, let's talk about reference point. What do you mean by reference point? Consider a rectangular coordinate system consisting of three mutually perpendicular axes labeled x, y, and z axis. The point of intersection of these three axes is called origin and serves as the reference point. That means whenever you want to measure the distance, you have to start from the origin alone, taken as the coordinates. that is x comma y comma z, of an object describe the position of the object with respect to the coordinate system. The coordinate system along with a clock to measure the time constitutes a frame of reference. I repeat, the coordinate system along with a clock to measure the time constitute a frame of reference. Positive direction. Generally, the positive direction of an axis is in the direction of increasing numbers. That means you can move towards positive x, positive y and positive z. Negative direction. The negative direction of an axis is the direction of decreasing numbers. Decreasing number means you have to move opposite to the positive like this and positive to z direction like that. While describing motion, we use a reference point or horizon with respect to which the motion of other bodies are observed. We can use any object as a reference point. For example, a car at rest or in motion can be used as a reference point. So not only that, a particular object, any object can be taken as a reference object. When you travel in a bus or a train, you can see the trees, the buildings and the poles moving back. To a tree, you are moving forward, and to you, the trees are moving back. Both you and the trees can serve as a reference point, but motion cannot be described without reference point. So whenever you want to talk about motion of a particular object, you need some reference point. Without a reference point, we should not talk about motion of an object. Just think about it and try to answer this question. Horizon, unit and direction of position measurement of an object. Now let's suppose that I am going to take x-axis. Now O is the horizon and towards the right side it is positive, increasing number. Towards the left side it is negative, decreasing number. The distance measured to the right of the horizon of the position axis is taken positive and the distance measured to the left of the horizon taken as negative. The horizon for position can be shifted to any point on the position axis. That means you can shift the horizon to any particular point. The distance between 2 points on position axis is not affected due to the shift of horizon of position axis. That means whenever you are going to shift, the distance between the 2 points will not affect it. Horizon, unit and sense of passing time. Now I am going to take a time axis. You can see towards the right side it is increasing time, towards the left side it is decreasing time with respect to O. The time measured to the right of the horizon of the time axis is taken positive and the time measured to the left of the horizon is taken negative. The horizon of the time axis can be shifted to any point on the time axis, even here horizon of the axis. The negative time coordinate of a point on time axis means that the object reached that point a time that much before the horizon of the time axis, that is t equal to 0. The time interval between 2 points on time axis is not affected due to the shift in the horizon of time axis, just like position. When the same point is chosen as horizon for position and time, that is the horizon for position and time. When different points are chosen as horizon for position and time, this is the horizon for time and horizon for position. Both are at different points, so it will differ. But the distance between 2 points will not change or affect.